Hello, this is video CC, and this entire video is going to be a trace of the program example 9 we're up to, example 09.cpp, which is all about structures and pointers and all that stuff, so hang on tight. Trace of EX09, example 9. And away we go. The stuff at the top, the header block of comments, don't forget that, of course. Include IOStream using namespace std, always got to have that. The first original stuff for this program, struct Bunny. Bunny has 3 pieces. Now, normally I would draw the ghost picture of Bunny over here just as a visual reference, but I think we've seen enough of those now, I hope, that we can all visualize that together. I'm trying real hard not to step on a dog down here. So if we all come tumbling down, you'll know what happened. Tell them I was brave. I've got to take these off. Okay. Now I'm ready. The bunny has a name, the bunny has an age, and the bunny has a best friend forever, a BFF, which you'll notice is a pointer to another structure, just like we saw with cities in the last example. So mental note, every bunny has a name, has an age, and also has a pointer to another bunny structure. So we can link these together. And away we go. Inside the main program, there are 3 variables of type pointer to bunny. And how do I know they are? Well, the star out front. Bunny is the new homemade data type. That's a structure with a capital B by convention. Your bunny has a star out front. Temp bunny, goodbye bunny. They all have stars out front. So none of those are bunny structures. None of those are the 3-piece bunny structures. Each one of those is going to hold a hexadecimal value that points to a bunny structure. Now, normally with a trace, I would put all the variables at the top and just keep up with them throughout the life of the program. But to try to keep the picture as simple as possible, I'm going to experiment with not putting the variable on there until we actually need it for something. So the first variable that we actually see in use here is on line 24. The right-hand side, new bunny, says run off and find some place that's large enough to hold a bunny structure. Carve out that bunny structure and give me the address of it back to my program. A bunny structure, I'm going to abbreviate these in the interest of time. A space for a name, I'm just going to make that lowercase n. Space for an age, lowercase a. Space for a BFF pointer, lowercase b. Name, age, BFF, and now this has been officially carved out of memory. And what happens after it carves it out of memory? Well, it sends back the address, and we're putting that in variable your bunny. And here's what I mean. Your bunny has already been there, but we didn't use it until just now. So there we go. There's the picture as of line 24. As far so good? Then we start using that pointer immediately. Line 25 says, put a 0 here. Your bunny, arrow, BFF. Carefully drawn picture, arrow in the code, arrow in the picture. Your bunny, arrow, BFF is 0. Your bunny, arrow, BFF, 0. That's how we do it. What's your bunny's name? We're reading directly into the name field of your bunny, and Fearless User typed in Sniffles. So when they type in Sniffles, it goes directly into your bunny, arrow name, Sniffles. What else we got? How old is, and then we're already using the field we just filled in, so it's going to print out, how old is Sniffles? Because Sniffles is the value stored at your bunny arrow name. And user types in, I should have memorized these, 5. 5 goes into the age. All of that is up through line 29. Now, I'm going to be redrawing this picture a lot. I give you a warning. Because once you start playing with structures and arrows and all that stuff, oh, good grief, this picture gets so messy, there'll just be arrows flying around all over the place. It'll look like Custer's Last Stand. Let's look at line, moving on. I think we can do this without messing things up too much. Line 32, we bring Temp Bunny into play. Here's Temp Bunny. Temp Bunny equals new bunny. It's just going to point out a structure of its own. Now, every time we call new, by the way, it's never going to go back and get something that we've already asked for and gotten. It's always going to find a new chunk of storage. Maybe that's why they called it new. with a name, space for a name, space for an age, space for a BFF. It grabbed that. That's the right-hand side of line 32. And then we stored that address that's returned in our variable temp bunny, which is a pointer to a bunny structure. Bada boom, bada bing. And also, I'm experimenting with not making up hexadecimal addresses until perhaps I absolutely need them. And we'll just keep up with, this does have a hexadecimal value in it. That's the address of this. So if I pretend made up that this is hexadecimal 1000, then the current value of temp bunny would be hexadecimal 1000. It would hold the address of this bunny structure that we've carved out of memory. Moving right along, okay, line 33. Temp bunny arrow BFF is 0. Start on the right-hand side, 0. Put that at temp bunny arrow BFF. Temp bunny arrow BFF. Now you'll notice, I'm real quick to do that. That's a convention that is just so handy and so protective of us in its own way. Any pointer, we don't want to leave any pointer variables lying around that we might accidentally take a look at thinking, well, that points at something when in fact it doesn't. We'll always be able to test, and a pointer that has a 0 value doesn't point at anything valid. Who's your bunny's BFF? And we're already halfway through the program, can it be? And the user types in, who's your buddy's BFF? They type in Thumper. And Thumper goes on line 35. We're reading that directly into temp bunny arrow name. Thumper. So far so good. How old is temp bunny arrow name? How old is Thumper? How old is Thumper? Thumper's 12. We read 12 into temp bunny arrow age. Now, here's the first thing that goes on behind the scenes that's not actually asking the user for something or reading it in. Stare at line 38 until it makes sense. What's going on here? Well, we do this one piece at a time. Good thing we've learned well to start on the right-hand side and then look at the left. Start on the right-hand side of line 38, temp bunny. Temp bunny is a pointer to this. So I haven't shown it on our screen up here, but it actually holds some wild and crazy hexadecimal number that is the address of where that structure lives in memory. So that is what's on the right-hand side, the address of this, and we're putting it at your bunny arrow BFF. Your bunny arrow BFF. Now you might think we really can't do this assignment because I haven't made up the wild and crazy hexadecimal numbers, but you'd be wrong. Here's what we have to remember. Copy a pointer remember that. Copy a pointer variable value to another pointer variable, and you end up with two pointers pointing at exactly the same thing. Now, with that freshly in mind, if you got all that, look at line 38 again. The right-hand side, temp bunny is the address of this structure. We're taking the arrow, think of it that way. We're taking the arrow that points at this structure and stuffing it into the variable your bunny arrow BFF. Your bunny arrow BFF is this. So this will no longer be 0. This will be an arrow that points to that. Because I'm copying temp bunny, the address of where that lives, I copied that right here into your bunny arrow BFF. So I end up with two arrows pointing at the same thing. Okay? Now, new stuff is about to go on with temp bunny and so forth. So rather than trash this picture, and I actually do this a lot, I'm going to do a redraw. Redraw after whatever we just got up to, line 38. Line, spelled with an L. Line 38. Now what I do is, so that I can kind of look through the history of what's happened to all this wild and crazy arrow stuff and structure stuff and everything, I leave that alone, make a copy of it, and then all the trashing and Xing out and marking and everything will be done to my copy down here. So I'm going to abbreviate YB for your bunny. It's the same variable. Your bunny points at Sniffles 5 and a BFF pointer. Copy this as quick as I can, and that's what I'm doing. I'm just copying this picture. Sniffles 5. The BFF points at this structure over here. And I'm not going to put the value temp bunny pointing there because that's about to change. That's actually the very next thing that changes on line 41. So I'll still keep temp bunny. Let me see if I can justify what I'm doing here. I'm still keeping the temp bunny pointer, but you can see it's going to get a brand new value the very next thing on line 41, the very next thing after line 38. So rather than draw an arrow and immediately having to exit out, I'm just going to remember, okay, Temp Bunny right now is pointing here, so that way I don't have to draw an arrow and exit out and mess up my picture. So the name, Thumper, the age, 12, the BFF, nobody, 0. Now, here's what I'm talking about. Line 41, Temp Bunny gets a new value there. So it really is copying over the arrow that's there right now that I didn't draw in, because I'm trying to be neat and clean and not messy. So Temp Bunny gets the address of a brand new bunny structure right here, with space for a name, an age, and a BFF. That address gets returned and stored in variable Temp Bunny. All that happens on line 41. And immediately, before I don't forget, let's adhere to the convention. Line 42, put a 0 in Temp Bunny 0 BFF. It's almost like an initialization we're doing for that structure. Solomon's getting closer and closer. Whose, and your bunny arrow name, your bunny arrow is right here. Your bunny arrow name is Sniffles. Whose Sniffles' new BFF? Oh no, Thumper's going to get demoted. But we're just asking questions here right now. Whose Sniffles' new BFF? And we read in, who's Sniffles' new BFF? Roger. Roger goes right here. That happened on line 44. CN, Temp Bunny arrow name. Temp Bunny arrow name is that field right there, and the user typed in Roger. Line 45 turns around and prints the name back out. How old is Roger? How old is Roger? Roger's 3. We read that directly into the age field. Okay? Now, relatively innocent looking statements, or so I'll claim, but we got to be very careful with line 47 and 48. All this pointer manipulation and stuff, you could think of that as going on behind the scenes. These are memory addresses, and we're just slinging them around in the background back there. But we've got to keep our picture up to date, because there's not going to be any direct way to see whether or not it does what we intend. Good grief, what a disclaimer. Look at line 47. First of all, let's track down the right-hand side. Your bunny arrow BFF. Let me find that in my picture. Notice how the picture is just going to help so much. Your bunny arrow BFF. Your bunny arrow BFF. That's the right-hand side. What's the value? Mental note. The value of your bunny arrow BFF is the address of where the Thumper bunny structure is in memory. Maybe I should have been using hexadecimal addresses, and if I have to, I'll go back and redo this video using hexes instead of arrows. But for now, let's just say, well, let's not just say, let's just realize the right-hand side of line 47, your bunny arrow BFF, your bunny arrow BFF is this arrow that points to Thumper. It's the address of Thumper in memory. That's the right-hand side. Where are we putting the arrow that points to Thumper? We're putting it into Temp Bunny arrow BFF. Temp Bunny arrow BFF. We just initialized it to 0 for safety, but now it's getting a new value. It's getting the arrow that points to Thumper. We're copying that from right here. So this is no longer going to be 0. This is going to be an arrow that's pointing to Thumper, and Thumper's getting a lot of attention all of a sudden. That happened on line 47. We copied this arrow, the address of structure Thumper. We copied that into Temp Bunny arrow BFF. Copy a pointer to a pointer, you get 2 pointers pointing to the same thing. Well, we're not done. Line 48. Get the value of Temp Bunny itself. Temp Bunny itself points to the structure that has Roger. That's the right-hand side of line 48. What's on the left? Where are we putting Roger's address? Roger's address is going into your bunny arrow BFF. Your bunny arrow BFF. So we're copying this Temp Bunny arrow right here, the address of structure Roger. We're copying that right here, which means that Sniffles no longer is going to point at Thumper as its BFF. Can I do this without crossing arrows, perhaps? Way over here, your bunny arrow BFF will now hold the address of structure Roger, because we copied that from Temp Bunny. Let me repeat that. Line 48. I know this is new stuff. The right-hand side, Temp Bunny all by itself is the address of where structure Roger lives in memory. We're taking the address of structure Roger and storing it at your bunny arrow BFF. Follow the arrows. Your bunny arrow BFF. We copied the arrow that points to Roger right here, so we ended up with 2 arrows pointing to Roger. Okay? Now, time for a redraw. Wraparound is one of the new recurring themes of this course. Finish off the bottom of the whiteboard and then start again at the top. What I'm going to do, we just now did what? We did line 48, so this is going to be another redraw. For clarity, it's always a good idea to redraw the picture rather than just keep going and marking out errors, and all that stuff. So this is redraw after line 48. One of the things you get to do when you redraw it is you just leave out any dead arrows, you leave out any marked out zeros or whatever, and you can also put things in a straight line. Here's what I'm talking about. The first one over here is still going to be your bunny, which I'm still going to abbreviate as YB. Your bunny is still Sniffles, age 5. Still has a BFF, but look at this. This arrow is just stretched way over there. The next one after Sniffles is not Thumper anymore. The next one after Sniffles is actually Roger. So I'm going to pull Roger way over here. It's like I'm just sliding him around. Roger is the one that's pointed at by the BFF pointer of Sniffles, like so. Name, Roger. Roger's age is 3. And look at this. Roger's BFF is Thumper. So the list, if we're going from left to right, actually goes like this. Sniffles over to Roger, then back to Thumper. So I'm straightening that out up here so it's easier to keep up with who points at who. Name, age, BFF. And let's see if I got everything copied. No. When I put Roger here with 3, it has as its BFF a pointer to the Thumper structure. And Thumper's age is 12, and BFF is 0. Now, since I've redrawn it, I'll go ahead and free up board space for the next time I need it. This is the current state of affairs as of line 48. Oh, this. 1 second, I'm sorry. This dark green, I should have remembered. It's the hardest one to erase. Okie doke. After line 48, where do we go? Here are your 3 bunnies, it says. So it looks like we're coming in for a landing here. Temp Bunny. That line's in their way now. Isn't it? No? Actually, Temp Bunny. I could put that at the top. Okay. Temp Bunny. It's a pointer, so I don't need to make it real big. Temp Bunny equals your bunny. On line 52 is where I'm looking. First of all, it said, here are your 3 bunnies, and then it says Temp Bunny equals your bunny. Here's your bunny. We copy that to Temp Bunny. Repeat after me. Copy a pointer to a pointer. You end up with 2 pointers pointing to the same thing. That's exactly what happened there. Now, here's a strange little quirk of C++. It doesn't look like you should be allowed to do it, but you are. Here's the point to ponder and something to remember as long as you program in C++. If you force something, called coercing it, if you coerce an expression into performing or behaving or being interpreted as a logical expression in an if statement or a while statement, C++ will always do this. It'll say if it evaluates to absolute 0, it's false. Anything else is true. The string sunset in double quotes, that's true. Why? Because sunset in double quotes is not 0. If it's absolute goose egg and you force it to be viewed as a condition, it's false. Anything else is true. So let's look at that. 53 doesn't look like a condition at all, does it? It actually is Temp Bunny. Temp Bunny is the address of this. I don't know where this lives. I didn't even make up a hexadecimal address for it, a pretend one, but I do know that it's not 0. Memory address 0 is not something valid in my program. So what that's doing, line 53 is actually exactly equivalent to this. Listen carefully. While Temp Bunny is not equal to 0. That's an equivalent condition. While Temp Bunny is not equal to 0. As long as it's got a non-zero value, let's keep going. So we're going to get in there at least the first time, and it's going to tab over and print out Temp Bunny Arrow Age. Temp Bunny Arrow Age will be 5. 5-year-old, Temp Bunny Arrow name, 5-year-old Sniffles lives at, and here we go. I think I said maybe quickly so it didn't scare you away or anything. I said you can. You don't have to dereference pointers. You can print out pointers if you want to. And sure enough, line 55, Temp Bunny. If we just print out bold, naked Temp Bunny without any stars or ampersands or anything else, then it shows me where that lives. It shows me the address. And when I run it on this machine, let's see. Temp Bunny, no, 5-year-old Sniffles lives at, and it lives at 0x. That's how, when you print out a pointer, when you print out a hexadecimal pointer, that's what it does to let you know now we're looking at hexadecimal. And I'm looking at the output on minus line 93. Lives at hexadecimal 711730. I'm going to stick to my own convention and just use the last ones. I'm going to say that this lives at hexadecimal 1730. That's not made up. That's the last 4 digits of the actual hexadecimal address of where Sniffles lives in memory. Not pretend. This is real. Bunny poop just got real. That's where it lives. I regret saying that. I'm sorry. I might have to re-record this video for future use. At any rate, that's where 5-year-old Sniffles lives, hexadecimal 1730. And I lost my place. We're in a while loop. Yes, we are. Okay, so now we're back. We're in the while loop. While Temp Bunny, well, it just did the cout statement, so now I'm at line 56. Look at line 56. Look at that very carefully. The right-hand side. Always look at the right-hand side first. Let's find, in this picture, let's find Temp Bunny Arrow BFF. Temp Bunny Arrow BFF is this. It's the arrow to Roger. So I'm taking the arrow to Roger, the address of Roger, and putting it in Temp Bunny. Say that again. Temp Bunny Arrow BFF is the address of where Roger lives in memory. I'm taking the address of where Roger lives in memory and putting that into variable Temp Bunny, which is going to overwrite that arrow. Your eyes deceive you. There is no arrow there at all anymore. It's just like copying over an integer variable's value of 0 with 5. That 0 was completely gone. I just now completely obliterated Temp Bunny's arrow to Sniffles, and now Temp Bunny can only see structure Roger. That's the bottom of my while loop. It goes back up and tests the weird-looking while condition on line 53, while Temp Bunny, I don't know what it is, but it's not 0. So Temp Bunny is true, and it will execute the while loop. Tab over, Temp Bunny Arrow Age, 3-year-old Roger lives at, and here we go again, we get another weirdo hexadecimal address. Roger lives at, last 4 digits, that looks like, I can't even read that close up, 5AD0, hexadecimal 5AD0. That's still a valid hexadecimal number regardless of whether or not I copied that down correctly. I was looking at line 94. So, 3-year-old Roger lives at something 5AD0. And what? Then we hit the Temp Bunny crawl. Well, I don't want to call it crawl. Line 56. We're moving down the line here. Temp Bunny Arrow BFF. Temp Bunny Arrow BFF is now the address of Thumper on line 56. I take the address of structure Thumper and put that in Temp Bunny, and once again, I'm trashing the arrow that Temp Bunny already had and replacing it with an arrow to a different structure. Goes back around, a while loop. How's it going to know? Do I need to execute? Do I not? Well, it looks at the value of Temp Bunny. That is certainly non-zero. Otherwise, it's not a valid address of structure Thumper in memory. So here we are inside the loop again. Tab over. Temp Bunny Arrow Age. And Thumper's age is 12. Temp Bunny Arrow Age. No. Temp Bunny Arrow Age. 12-year-old Thumper lives at, and here we go, another hexadecimal address. 5A90. Last 4 digits. 5A90. Now, there is some internal logic to those numbers, but I don't know what it is. I'm just believing what they tell me. While we're doing addresses, I might as well fill in another address here. This goes somewhere else on the board. If this is the address of structure, I'm putting Thumper on hold, by the way. Sniffles. If Sniffles really does live at hexadecimal 1730, then look at this. That must be the value that's stored in variable your bunny up here. So I'm going to have to expand this. I might as well write out the name. Bunny. That's a pointer variable. It holds the address of Sniffles. And we've already seen from the output that Sniffles lives at hex 1730. So there, all that avoidance of hex numbers, and here they are in grand style, showing up all over the place. Your bunny has hexadecimal 1730 because that's the address of Sniffles. You know what? I'm going to just completely hexadecimalize this picture. That's a new verb. If that is the address of where Roger lives, then that means that your bunny's BFF is hexadecimal 5AD0. Rogers, almost said Mr. Rogers. Roger's BFF is Thumper. Thumper lives at 5A90, hexadecimal 5A90. That must be the value stored in Roger's BFF, if Roger points to Thumper, because that's where Thumper lives. And one more, just to completely lose our minds here, the current value of Temp Bunny, it didn't leave room, I'm not going to write it. Current value of Temp Bunny is hexadecimal 5A90. That was printed out directly in the output. That's printed out on line 55. It's printing out Temp Bunny, so we know without even updating the picture that it's at FA90. And I've completely lost my place. Did we print out Thumper? 5A90 is not 0, so it prints out, 12-year-old Thumper lives at, and puts the address 5A90. That's how I knew where Thumper lived. So we're at the bottom of the loop again, and the loop is still going. Watch this. Line 56. Temp Bunny arrow BFF. Temp Bunny arrow BFF is goose egg. We've got a 0, but we're not stopping there. Look, that's the right-hand side. We're copying that into Temp Bunny, big, bold as I can make it, even though there's not any space left. We just got through copying a 0 from Thumper's BFF into Temp Bunny 0. That is not a valid pointer value. If we try to say Temp Bunny arrow name right now, crash and boom. Our program is done, and not in a pleasant, happy way. But that's the bottom of the loop. Let's go back around and try the while condition again. Look at line 53 now. While Temp Bunny. Condition's false. Temp Bunny is 0. That's false. If we force pointer variable Temp Bunny to play the role of a condition, and Temp Bunny has value 0, then that condition is false. And we fall out of the while loop. We're gone. Okay? So finally, maybe you thought we would never get there. Finally, we fall out of the while loop that started on line 53 and talk about arrows. Oh my goodness, look at this. All the stuff starting on line 60. Not only is that one big, long cout statement that goes on for lines and lines, but it's got arrows all over the place. Let's see if we can even keep up with it. What it's trying to do is show you that these pretend hexadecimal values, they actually have real live hexadecimal numbers that are being used in the computer. Address of ... it says. Now, you can look at the output. I'm going to look at the picture and hope that I get this right. But the output for this little section here starts on line 97. So you start looking at line 97 while I start reading off what's going on here. Your bunny, address of your bunny, it prints out the value variable your bunny, so it should print out the number that ends in hexadecimal 1730. That should be the first hex number we see. Then it prints out your bunny arrow BFF. Your bunny arrow BFF, it should print out 5AD0. It should print out the hex address that ends in 5AD0. Why? Because that is your bunny arrow BFF. The plot thickens. The next line prints out your bunny arrow BFF, arrow BFF. Your bunny arrow BFF, arrow BFF. That should print out 5A90. I keep forgetting to say it. That should print out the address that ends with 5A90. And then finally and mercifully, we do 3 BFFs in a row. Arrow, arrow, arrow. Your bunny arrow, BFF, arrow, BFF, arrow, BFF. And there's the one we got to be careful with. Should print out 0. If I go 3 BFFs away from the starting point over here, it should be 0. And I don't remember what I said, but the addresses that we see in order are 1730, because that's the address of the first one. Then we see the one that ends in 5AD0. That's the address of the second bunny. Then we see the address that ends in 5A90. That's the address of Thumper, the third bunny. And then that last BFF is Thumper's BFF. That's 0. How did we get there with all those arrows? If you've drawn the arrows, well, these are kind of messy now. I apologize. Temp Bunny did that. If we follow the arrows, 1, 2, 3, then there we are. There were 3 arrows to get to that last BFF. Okay? Now, let me see here. It's time for a redraw, isn't it? This is the grand finale redraw. So, hang on. I messed up that picture unmercifully. Your bunny. I'll go ahead and get the bunnies here. Name, age, BFF. Name, age, BFF. Name, age, BFF. And I know that the pointers are like that because they were the last time I drew the picture. That one's 0. I knew that without looking. Sniffles is 5. Roger is 3. And Thumper is 12. And at this point, this top half is just a messy distraction, so I'll get rid of it. There. Here's where we are coming into the last section. I could label this as after line whatever, but I think this is the same picture we had as after line 48, if I'm not mistaken. So really, it's just a redraw of this to clean it up. Get rid of the arrows that we're not paying any attention to anymore. And then we start the last section on line 68, Temp Bunny equals your bunny. Here's Temp Bunny. Temp Bunny equals your bunny. Copy a pointer to a pointer. You get 2 pointers pointing the same thing. While Temp Bunny, well, we've seen that loop before. That's checking to see if Temp Bunny has a non-zero value, and it does. Uh-oh. Storms are brewing. The angel of death. Goodbye, bunny. I'm going to put that down here. Didn't leave much space for it. Well, let's see what Goodbye Bunny is going to do. Oh, no. Don't have a good feeling about this. Line 70, the right-hand side. Temp Bunny. That's the address of Sniffles. Poor Sniffles. Goodbye Bunny equals Temp Bunny. 2 arrows pointing at the same thing. Can you see that? Move Solomon. Look at this. Temp Bunny equals Temp Bunny arrow BFF. Temp Bunny's value is going to change. The right-hand side is Temp Bunny arrow BFF. Temp Bunny arrow BFF is the address of Roger. So we're taking the address of structure Roger on line 71 and making that the new value of Temp Bunny. Like so. That's as of line 71. See ya. Goodbye. Goodbye, bunny arrow name. Goodbye, Sniffles. Exclamation point. Delete Goodbye Bunny. Delete Goodbye Bunny does that. Poof. Sniffles is gone. Just like that. We'll say they're backstage. It was just one of those hat tricks by a magician. But that's the bottom of the loop. Comes back around while Temp Bunny is non-zero. Temp Bunny points at Roger. Then line 70 says, copy Temp Bunny, which is the address of Roger. Copy that into Goodbye Bunny. So now Goodbye Bunny crept up on Roger. Temp Bunny equals Temp Bunny arrow BFF. And I'm even reading those in the wrong order. We start on the right-hand side. Temp Bunny arrow BFF is the address of Thumper. So we're copying on line 71, copying the address of Thumper into Temp Bunny, like so. Just in the nick of time. Goodbye. Goodbye, bunny arrow name. Goodbye, Roger. And then we delete Goodbye Bunny. It gets rid of Roger. Poof. That's the bottom of the loop. While Temp Bunny does still point at something. So it's not 0. Goodbye Bunny equals Temp Bunny. So we're copying the address of Thumper into the Goodbye Bunny pointer down here. I told you these pictures get messy, and I just got through redrawing this. Oh my goodness gracious. But at any rate, I copied Temp Bunny into Goodbye Bunny. Temp Bunny equals Temp Bunny arrow BFF. Watch this. Temp Bunny arrow BFF is 0. Is copying 0 into Temp Bunny, so there's no valid arrow at all. Temp Bunny, once again, doesn't have space to show it, but Temp Bunny has value 0 now. It doesn't point at anything valid. Goodbye Bunny arrow name. Goodbye Thumper, it should say. Delete Goodbye Bunny, all gone. And then while, it goes back around, while Temp Bunny, that falls through. Look how we're using the 0. I didn't mention this, but I'm going to mention it now. If we've got 0 in a whole string of bunnies, a whole string of cities, a whole string of cats or dogs, or whatever we strung together like this, if we've got 0 as the last one, that is very, very much like a sentinel value at the end of a list that we're reading. That's how we test and see that we've gotten to the end of the line. And we need to stop deleting and stop printing goodbye messages. So that convention is just so useful right here. When we finally copy a 0 as the last BFF into Temp Bunny, we know we've seen all the bunnies. We've gone back and whacked all the bunnies. Sniffles is gone, Roger's gone, Thumper's gone. There's nobody left. So that's why the while loop can fall out. Now, if we wanted to be very, very careful and dot all the I's and cross all the T's and all that stuff, then we probably, before we print out the all gone message, we probably want to set your bunny to 0, just like Temp Bunny is. And, you know, in retrospect, I wish I had done that now just to be a good example to you. But it doesn't really matter because we're about to shut down the program. It prints out all gone and returns 0 and we're done. I haven't checked the output in a long time. It should have said goodbye Sniffles, then goodbye Roger, then goodbye Thumper, and it did, and all gone. All gone. Yeah, these things are even hard to trace, but it is absolutely worthwhile because if you can't draw the picture and follow along, then you can tell by looking at this, it's going to be impenetrable. That's a word I don't use very often. It's going to be so hard to figure out what the hey is going on if you don't draw a picture and keep up with it. Okay, that is example 9. Goodbye, example 9. I'll see you online.